Welcome to Hartman Math. This is lesson 8.4, geometric series. We're going to start by trying to develop the formula for a geometric series. So we're going to look at what it would look like to create it. Remember when we were looking at arithmetic series, it was capital S for series or sum, sub n. So we're adding up the first n things. And the first one would be a sub 1 plus. And if we're talking about geometric, remember, we take the previous one and we multiply by the r value to get the next one. So the first one times r is the second term. And then the next term is that times r. So a sub 1 times r times another r makes a sub 1 r squared, and so on. And then remember, our formula for the geometric was a sub 1 r to the power of n minus 1. That would be our last term. So that would be the nth term right there. Because remember, a sub n was the formula. So now, algebraically, what we're going to do is we're going to write a new equation where we multiply all of those by r. So we're doing r times s sub n. If we multiply this by r, we get that. And I just chose to kind of stack it under what would be a like term. If I multiply that by r, I get that. If I multiply that by r, I get a sub 1 r cubed. And remember, because of the dot, 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 there would be a sub 1 r cubed right there, and so on. If I multiply the one before this, which would be a sub 1 times r to the n minus 2 by r, I get that one. And if I multiply this by a sub 1, multiply by r, remember that if we multiply by with like bases, we add the exponents. N minus 1 plus 1 is n. So now what we're going to do is we're going to take these two equations. We kind of have a system here. And we're going to subtract the equations. We're going to do that straight down in columns. So these are not quite like terms. We'll go this minus this. We're going to keep them separate. And then this minus nothing is a sub 1. This cancels. This cancels. All these columns cancel. And the last one is 0 minus this is negative a sub 1 r to the n. So we had a lot of canceling. Now what we're going to do is we're trying to get s sub n all by itself in terms of the other things that we have here. So we have two of these s sub n's. To get one, I think I'm going to factor this. Factor out the greatest common factor. So if I factor out s sub n, I get a 1 minus an r in the parentheses. And over here, also have a greatest common factor. I'm going to factor that out. I'm going to factor out the a sub 1. And then to finish this off, since this is multiplication, I'm going to divide both sides by the 1 minus r. And there's my formula. Now in a lot of books, you're going to see this on the bottom without the parentheses. I choose to have the parentheses because it's going to help when we use calculator. We're going to want those parentheses because above and below fraction bars assume parentheses. There's our formula. So to add up in a geometric series, the first n things, we need to know the first, r, and how many. So example number 1, our series here, plus, 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 series, dot, 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 is geometric because multiply by 7, multiply by 7, multiply by 7. Remember, if it was adding the same thing, that would be arithmetic, and we would use the different formula. This is geometric. We're going to do s sub 8. 3 things we need to know. A sub 1. R, remember the pattern, what was multiplied by. And if we can't quite figure that out, if we know it's geometric, just take one of these and divide by the one in front of it. 14 divided by 2 is 7. That's our r. And that's how many. So those are the 3 things we need. And we should be able to type it into the calculator just like this, get an answer. pretty big answer. Because again, remember the sequences get big, so when we add them up, that gets big too because of the multiplication. All right, you try find the sum of the first 6 things without just doing it by hand. You got to show the work. All right, pause here, finish up, resume when you're ready. All right, so we should be able to directly calculate this. We're doing S sub 6, so we know N. We know A sub 1. The R, take the 12, divide by the 24. I think we're going to get 0.5. That is an exact decimal, so we're okay with it being a decimal. We should be able to type it in just like that. 96 times 1 minus 0.5 to the 6th, close parentheses, divide by parentheses again, and that equals 189. Example number 2, we did something similar for arithmetic back then. Find the sum, adding them up. Here's our issue. We know A sub 1. I think we can figure out the R pretty easily. We don't know N. We don't know how many terms this is because we don't really know what's missing. And we're not allowed to just write it all out. We have to show the algebra. So we're going to go back to previous lesson and do it as an A sub n sequence focused on this term because we want to know the position, the n that goes with that term. So we're going to say A sub n, which is that, is equal to A sub 1 times r to the power of n minus 1. So the term that we're interested in, 9 times 4 to the power of n minus 1. So we're going to solve for n. We can get rid of the 9, just divide both sides by 9. So now we've got some choices here. We can do guess and check. I'm okay with that. Or we can bring this down, which means logarithms, which means rewriting this as a logarithm. So to rewrite it in log form, n minus 1 equals, the base moves to the other side, base 4. I don't know, we would necessarily know that one off the top of our head. So if we're going to do this with a calculator, that's the change of base formula. Log 16,384 divide by log 4. And that's going to say 7. And then we got to add 1 to both sides. We get n equals 8. So this number right there, that's 7. 7 equals n minus 1, so n equals 8. Now we're ready. We got all the stuff we need. We're going to do S sub 8. A sub 1 as our R was 36 divided by 9. That's how we got the 4 to the power of 8. All those parentheses. Type it carefully into the calculator. We should be getting 196,605. The sums, what they look like in sigma notation. Remember, this is the capital Greek letter sigma, the lower limit of summation, the upper limit of summation. If it looks exponential, like a times b to the power of x as an exponential expression, that's when it's going to be we know it's a geometric series. So I think we're probably good on all this. If we want to take a look at what the series looks like so we can kind of decode what some of the information is, plug in a 1. 1 minus 1 is 0. 5 to the power of 0 is 1, 0 exponent property, times 3 is 3. Let's plug in a 2, see what happens. 2 minus 1 is 1. 5 to the first power is 5. Times 3 is 15. Let's try another one. Plug in a 3. 3 minus 1 is 2. 5 to the second power is 25. Times 3 is 75. And so on. So that question is, what is the R value? What are we multiplying by each time? It's the 5. So it's the base of the exponent. That's going to be your R every time. So it's right there. Whatever's being raised to the power, that's your R. So I think we know everything. We're going to do S sub 10 is equal to, as we found out, we plugged in a 1 to get that first term, the 3. Okay? If this changes, that may not always be this. So to be safe, always plug in a 1 to find your A sub 1. And if we wanted the last one, we could plug in a 10. I don't think we really need that actually to find our sum. Because our sum of the first 10 terms is A sub 1 times 1 minus R to the n. So we're talking about 10. Ready to put that into the calculator. What are you going to get? 7,324,218. That's it for today. I'll see you next time.